The principle of mathematical induction. Let us understand what is an inductive set. A set S is said to be inductive set if 1 is an element of S and X is an element of S, imply X plus 1 is an element of S. N, which is the set of natural numbers, is the smallest subset of R, which is set of real numbers, which has this property. Let us derive a formula for the sum of natural numbers, that is an expression to calculate Sn equal to 1 plus 2 plus 3 up to summation of n. For n equal to 1, S1 is equal to 1. For n equal to 2, S2 is equal to 1 plus 2 equals to 3. For n equals to 3, S3 is equal to 1 plus 2 plus 3 equals to 6. For n is equal to 4, S4 equals 1 plus 2 plus 3 plus 4, which is equal to 10. For n5, S5 equals 1 plus 2 plus 3 plus 4 plus 5, which is equal to 15. Suppose it strikes us that Sn equals to 1 plus 2 plus 3 plus 4 up to n equals n into n plus 1 by 2 is the correct formula. How can we prove it to be the correct formula? We can, of course, verify it for many natural numbers, but not for all. We need to have some kind of chain reaction in which we prove the formula for the general case and it gets proved automatically for all the natural numbers. Let us study such a chain reaction called mathematical induction. Let's prove the formula 1 plus 2 plus 3 equals to n into n plus 1 by 2, that is summation of all natural numbers up to n equals to n into n plus 1 by 2. Following are the steps involved in proving it. Step 1. Assume the statement to be denoted by Pn or Sn, etc. That is, Pn is the statement 1 plus 2 plus 3 up to sum of n equals to n into n plus 1 by 2. Step 2. Check if the statement is true for n equals 1. P1 is 1 into 1 plus 1 by 2, which is equal to 1. Note that here the statement is true for all n greater than or equal to 1, but we may find statements which are true for n greater than equal to m, where m is a natural number, m not equal to 1. Then we check that statement to be true for n equal to m, that is Pm. Step 3. Assume that Pk is true for some natural number k, that is Pk is 1 plus 2 plus 3 up to k equals to k into k plus 1 by 2. We have assumed that this is true. This is called the inductive step. The assumption that n equals to k is true is called inductive hypothesis. Step 4. Prove that Pk plus 1 is true. We have to prove Pk k plus 1 equals 1 plus 2 plus 3 plus up to k plus 1 equals k plus 1 into k plus 2 by 2 is true. Here, the left hand side is 1 plus 2 plus 3 plus up to k plus 1, which is equal to k into k plus 1 by 2 plus k plus 1, since we have assumed pk is true in step 3. Let us simplify the left hand side of the equation. The left hand side is k into k plus 1 by 2 plus k plus 1. Let us take k plus 1 common out of it. So we get k plus 1 into k by 2 plus 1, which on simplification gives k plus 1 into k plus 2 by 2, which is equal to the right hand side of the equation. Thus, pk plus 1 is true whenever pk is true. Hence, from the principle of mathematical induction, the statement Pn is true for every n belonging to the set of natural numbers.